Okay, so let's turn to another example here. This time I want to look at the sum as k goes from 1 to infinity of 1 over k squared. So we would look at the integral from 1 to infinity of 1 over x squared dx. Right, we would rewrite that as a limit as b goes to infinity of the integral of x to the minus second dx. Right, and then we start working that out. We apply our integration rule. X to the negative second, so we don't have to do any substitution or anything here. We just go ahead and add 1 to the x wanted. Make that x to the negative 1. And then we would divide by the negative 1, so it would be negative 1 over x. And that's evaluated between 1 and b. Between 1 and b. So we start to work that out. That'll be the limit as b goes to infinity of negative 1 over b plus 1. Okay. And then we allow b to go to infinity, and this time 1 over b will go simply to 0. Right? 1 over b will just go to 0. And so therefore, this thing is equal to 1. So now we know the integral, the improper integral converges to 1. Now what the result tells us, again, is that either both the integral and the series converge or they both diverge. So since the integral converges to 1, what we can say is that the series 1 over k squared converges. Now we cannot say that the series actually converges to 1. All we can say for sure is it converges. Okay? These things, the integral and the series, they're not necessarily the same. Okay? Just because the integral converges to 1 doesn't mean the series will converge to 1. It might, but what we do know is that at least it converges. Okay? At least the series does converge. Does it actually converge to 1? I don't know. That would be a good question to ask, but what we do know is that it does converge.